An equilateral triangle has sides of length 2 and angle measures of 60 as shown below. The altitude from one vertex to the opposite side divides the triangle into two right triangles. So as you can see, we have an equilateral triangle. That means all sides are equal, all angles are equal, and we're being asked whether or not the two triangles are congruent with the altitude drawn in the middle. So they are congruent because we can prove them congruent by angle, angle, side. And we're being asked what the length of the shorter leg of each of the right triangles are. Well, if we know the entire length here is 2, and since we have this altitude, it is also the median of this equilateral triangle. So that means this length of 2 is divided into 2 equal parts, so that each of these legs is worth 1. So we're going to use the Pythagorean theorem to determine the length of the altitude. So we know that the length of the leg is 1, the other leg is the altitude, and the hypotenuse was 2. Okay, so the length of the altitude is a radical 3. So we're going to write the ratio that represents the shorter leg to the hypotenuse. That's a 1 to 2 ratio. And we're going to write the ratio that represents the longer leg to the hypotenuse. That is a radical 3 to 2 ratio. And the ratio that represents the shorter leg to the longer leg, that's a 1 to radical 3 ratio. And since we have these ratios, we're able to use them for any 30, 60, 90 special right triangle. And we can find any length of these right triangles. So the summary of the 30, 60, 90 right triangle goes like this. Since we have a 1 to radical 3 to 2 ratio, doesn't matter what the value of the side is that's across from the 30-degree angle. That's the one we start with. But we take whatever that value is and either multiply a radical 3 to it to get the length of the longer leg, and we multiply a 2 to it to get the length of the hypotenuse. So in a picture, we have our 30, 60, 90. Across from the 30 is going to be the length of the smaller leg. Across from the 60 is the length of the longer leg. So we take the smaller leg and multiply a radical 3 to it. And as far as the hypotenuse is concerned, we're going to double the length of the smaller leg. So in example 1, it says that by the angle-angle criterion, any triangle with measures 30, 60, 90 will be similar to this triangle. If a 30, 60, 90 triangle has a hypotenuse length of 16, what are the lengths of the legs? So I'm going to draw a picture of that because I'm a very visual person. And here's my 30, here's my 60, here's my 90. And the hypotenuse has a length of 16. So now think about it. If you look back up top where it has the summary of the 30, 60, 90 right triangle, and I'll outline it, we're looking for the length of the other legs. We're going to look for the one, or the shorter one, or the smaller one, the one that's across from the 30-degree angle. So whatever the length of that is, we double it to get the hypotenuse. So what did we double to get a 16? So what times 2 is equal to 16? If you think backwards, it's equal to 8. And all you have to do is take the length of that side and multiply it to a radical 3 in order to get the longer length. because of this ratio. In a 30, 60, 90 triangle, the short leg has a length of 5. So the short leg is across from the 30-degree angle because that's the smaller angle. What are the lengths of the other leg and the hypotenuse? Well, we know that it has a 1 to radical 3 to 2 ratio. So if the 5 is representing the 1, then we take the 5 and multiply a radical 3 to it to get the length of the longer leg, and we double it, so that gives us 10 in order to find the length of the hypotenuse. An isosceles right triangle has the length of 1 as shown. So as you can see that they have two congruent sides. What are the measures of the other two angles? Well, we know that in a right triangle, the sum of the two acute angles are equal to 45 degrees. Or equal to 90 degrees, excuse me. So if you solve for that, so x plus x is equal to 90, we get 45 degrees. Okay, and we know that the angle measures are the same because opposite congruent sides are congruent angles. So what are the measures of the other two angles? We just found that out, and I just explained it. So use the Pythagorean theorem to determine the length of the hypotenuse of the right triangle. Okay, so we have 1 square plus 1 square is equal to c square. Pythagorean theorem, a square plus b square equals c square. So 1 plus 1 is equal to c squared. We get 2 equal to c squared. Take the square root of both sides, and we get the square root of 2 is equal to c, hence the length of the hypotenuse. Is it necessary to write all three ratios? Shorter leg to a hypotenuse, which is a 1 to radical 2. Longer leg to hypotenuse, which is a 1 to radical 2. And shorter leg to longer leg. Well, there is no shorter leg and longer leg because they're both the same in a 45, 45, 90. So that's a 1 to 1. Yes, I think it's necessary to write, one of these ratios, and we'll do that right now when it's asking us to write the ratio that represents the leg to the hypotenuse. So you should already know that in a 45, 45, 90, when you've got two equal angles, the sides opposite are congruent, so it's not necessary to write all three ratios, but it is necessary to write at least the leg to the hypotenuse ratio. So the summary of a 45, 45, 90 right triangle is a 1 to 1 to radical 2. We don't know what the lengths of the sides are, but whatever they are the same for the legs, and you just take that value and multiply radical 2 in order to get the value of the hypotenuse. Visually, it looks like this. X, 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 radical 2. So in example 3, it states that by the angle-angle criterion, any triangle with measures 45, 45, 90 will be similar to this triangle. If a 45, 45, 90 triangle has a hypotenuse length of 20, what are the lengths of the legs? Hypotenuse length of 20. We know we have a 45, 45, 90. And we want to find the lengths of the legs. We're going to have to go backwards. Okay, so whatever these two values are, they're the same. And it's those values times the radical 2, which is equal to 20. So I'm going to take x radical 2 and set it equal to 20 and solve for x. So we have to divide out radical 2 in order to solve for x. But we can't divide by radical, or we don't want, I can't say that, that's not true. We can divide by radicals. In this case, we can't. We have to rationalize the denominator. If we had a radical 20, then we would be able to divide out the radical 2, but we don't. So we're going to have to rationalize, and the way in which we do that is we take what's in the denominator, the radical 2, and we're going to multiply it to the top and bottom. And as a result, we get 20 radical 2 all over radical 4, which gives us, or simplifies to 20 radical 2 divided by 2, because the square root of 4 is 2, that's a perfect square. And then we can divide the 2 into the 20 and get 10 radical 2 as the value for each of the legs x. If a 45, 45, 90 triangle has a leg length of 20, so 45, 45, 90, leg length of 20, so that means they're both equal. What are the lengths of the other leg and the hypotenuse? Okay, so the other leg is equal because it's an isosceles right triangle. And the hypotenuse is take the value of the length of the leg and multiply it to a radical 2 in order to get the hypotenuse.